8 years ago this week, Firefox killed the blink element. Every year since, I enjoy dancing on its grave. And that's in spite of all of you out there resurrecting Blink with CSS animations. Because, as fans of the new wave post-punk security hour know, because your friends don't dance, and if they don't dance, well, they're no friends of mine. Which means, this week we talk with Maggie Jauregui from Intel about hardware hacking, from firmware flaws to triggering ground and arc faults with an eye towards safety. In the news segment, punk spiders, bug bounty budgets, vols in Zimbra, PyPI, eBPF, a vol list from CISA, and more. Everybody look at your hands and stay tuned for Application Security Weekly.
This is Security Weekly, for security professionals, by security professionals. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly. DisruptOps helps you find and fix cloud security issues fast. Getting bombarded with irrelevant alerts is frustrating. DisruptOps gives security and DevOps teams prioritized findings and routes relevant alerts to Slack or Microsoft Teams with automated response options that save you time. Finally, security is inside your workflow instead of in your way. Listeners can access the full platform free for 30 days by visiting securityweekly.com/DisruptOps. In any business today, there comes a moment, the moment you realize you can secure the code as fast as you write it. Instead of testing everything, you can just test the right things. It's not about tools, but intelligent risk management. That's the moment you choose Synopsys. Build secure, high-quality software faster. Visit securityweekly.com/Synopsys. Looking to improve your web application security? Probly is reinventing web application security. Probly focuses on the vulnerabilities that matter, eliminates false positives with evidence-based scanning, and provides a simple point-and-shoot solution that is easy to use. Probly's thorough coverage ensures accurate identification of vulnerabilities in any modern web application or API. Improve your web application security processes by visiting securityweekly.com/Probly and start your free trial today.
This is episode 160, recorded August 2nd, 2021. I'm your host, Mike Shima. I'm here with John Kinsella. Hello, John.
Hello there, friend of mine. How are you?
I'm doing quite well. I'm also quite interested in what sounds like an extension for the MCU. The Cyber Risk Alliance, in partnership with InfraGard, has launched the Critical Infrastructure Resilience Benchmark Study. Measure your readiness for ransomware by completing the survey and getting your score. Take the survey at securityweekly.com/CIRB. SC Media debuts its all-new SC digital experience, fully integrated with Security Weekly podcast content, just like us, and more. The new site increases the scope and scale of original content resources from editorial staff, contributors, and the far-reaching Cyber Risk Alliance network. Visit scmagazine.com to check out the new look. Maggie Jauregui is a firmware and hardware security researcher for Intel's Programmable Solutions Group. Maggie is part of the Black Hat USA Review Board and president of Security B-Sides Portland, the nonprofit organization that puts together B-Sides PDX. Throughout her career, Maggie has presented her research and delivered technical training on firmware and low-level platform security topics at conferences such as DEF CON, Black Hat, CanSec West, DerbyCon, NullCon, Hardware.io, OSFC, and B-Sides TLV. Hello, Maggie. Thank you for joining us.
Hey, Mike. Thank you so much for having me.
So we're happy to have you here because while we talk about application security, as the podcast name kind of gives it away, we tend to talk much more about the software side of things. So it's great to have you here to tell us about the hardware and firmware angle. And maybe just sort of to kick things off, we forget we as the podcast here maybe forget hardware and firmware a little more than we should. How does that look like in enterprise land? What does the security look like? Are people remembering their firmware security?
It's a complex problem, and it's partly because it's difficult to get visibility down there. It's something that has been overlooked because there's not a standard for the industry to look there. If you think about the IT environment of a company, for example, it's pretty diverse. It has multiple different ecosystems, depending also on the size of the company. They could have a data center, a factory, an office space, and multiply that by different geos. And does your company allow their employees to bring their own device and have phones where they can look at the IP as well? You have a wide variety of devices ranging from servers to desktops to laptops to phones. Each system, it's kind of its own little universe with different embedded systems that each require their own firmware. So without firmware, a computer is just a pile of hardware that doesn't know what to do. And we can never get to the actual applications, so we can secure those applications, right? So think of the firmware as the software required to run software, so to speak.
Yeah, and it sounds very much like this is the foundation. I think perhaps as you would describe this, of what we need is the root of trust, or the secure boot, so that once the operating system and the applications get into the picture, they know that they've at least they're operating within an ecosystem that ostensibly started off secure. And you hit a lot of different areas where firmware can come from, laptops to BYOD to IoT or OT. I'm not sure I have any other acronyms to throw out there. But looking at the firmware, you mentioned too maybe a little bit of visibility, just understanding what's going on in there. What about securing firmware itself, whether it's from the firmware that we have deployed or maybe the firmware that we're building or analyzing? Is it software like other software? Are there design decisions or other things that make it a bit more of a challenge or a different way of thinking as you approach it from a security perspective?
It is software in the same way, but it does have limitations that are very specific to firmware. Firmware is the code. If we think of the different little components within a platform, they all need to know how to boot up, what to do once they're boot up, how to communicate with other devices, and they don't always have all the memory or all the time in the world to do these different things. So the technology exists. We have ASLR and stack canaries and DEP, but that doesn't mean that it's always practical or feasible to implement those protections in low-level firmware.
So that starts to get, unfortunately, that starts to get a little bit maybe scary, frustrating, because for the decades of the application security community existing and seeing ASLR, seeing DEP, are good ways to basically have some countermeasures against memory safety issues. They're not fixing the entire class, they're just making it a little bit harder to exploit these, if you will. But if we're kind of throwing away or ignoring, I'm not sure what the kindest word to use there, of those types of security for firmware, are there some better alternatives that firmware developers can do to prevent attacks at that layer?
The first thing is admitting that we have a problem, right? Awareness.
Fair enough.
Just knowing that firmware is there, that we need to pay attention to it, understanding your particular company's threat model, because not everybody might care about the same specific things. So understanding your different ecosystems, the things that you want to protect, what you're not protecting against. And the fact that it's hard to get visibility into some of these things doesn't mean that it's always impossible. Some things can't be done, but there are a lot of others that can be done. So, for example, I always like recommending Chipset. Chipset is a great tool. It's open source, or Uefi tool, where you can look at your system and look at the configuration, how your platform was set up. Is everything locked and set up? Do your policies look okay? It's again a complex problem, because as time goes on, we find more and more potential little issues. If this isn't locked at the same time as this, then things can happen. So Chipsec is great in the fact that it's an accumulative tool where you can run it once on your system and get the red, green, and yellow response for this stuff looks good, this you might want to look at, these you probably should do something about. So Chipsec is probably one of those great, readily available tools that anybody could run.
Yeah, I think we have a link on our show notes to the GitHub project. It's fantastic resource. I'd love to hear some more about the aspects of things go wrong, and this could either be the things go wrong from the consumer perspective in the sense of what's my device doing, or can I trust my device is probably a pretty fair question, as well as on maybe the enterprise or the developer side about what could go wrong and how do I defend my firmware against these things. So tell us a bit more about just these something red pops up that seems bad. Just how bad can it be?
It depends. It depends on who you are. If you're a high value target and you're just walking through TSA, that could be that could be bad enough. But if, for example, your spy chip wasn't locked, then somebody might be able to write in there and either change some of your settings or drop some malware for future use and get persistence on your system. And more we've seen that these are things that aren't just theoretical, that actually exist. Recently, there was TrickBot, the Uefi Ransomware that actually goes on your platform and looks for spy vulnerabilities and abuses them to infect your system with ransomware, which is new and exciting for people like me, but it's the real world examples of things that exist out there. Like Mosaic Regressor is also like Uefi. It infects the OS through Uefi using the hacking team's implant, and then we have LoJax and other things. So these attacks are no longer completely theoretical. They do exist. They do happen, and one of the best things that anybody can do is try to stay up to date with their firmware updates, for sure.
So that's got to be on the one hand, patching is a quite oft repeated mantra, but patching firmware has got to be some extra challenges in there too, especially on the end user side, because I don't know that many devices actually have automatic updates for their firmware. But then even too on the developer side of this side of the fence, just pushing out patches possibly is not the most comfortable thing to do, especially on a regular basis. Even something like, or maybe I'll say this way, what even would be a regular basis for firmware patches? Because I'm going to guess pushing out firmware once a week probably isn't so easy.
It's not, and it also, again, depends on who you are, and if you are securing an industrial control system that supports critical infrastructure, then maybe you don't want to be updating your firmware every week. That may lead to some stability problems that are unacceptable for that sector of the industry. But it is important to keep in mind, because I think even just as consumers, we completely forget. The other day we were counting how many computers we have in the house, just in IoT devices, laptops, desktops, servers, phones, everything. And I like to ask people, like, when was the last time you updated the firmware on your Nest device or on your vacuum or on your fridge? And like you say, there's not always good automatic ways to do this. So awareness is the key thing, and devising a time frame that makes sense for your particular threat model.
Now, you described to everyone. Oh, go ahead, John.
Sorry, I'm curious to get that a little more, since you're coming at this really obviously from a firmware person's point of view. It's one thing to talk about UEFI on our Macs, on our desktops and things like that, like, a UEFI-based machine. But, we've covered this before. I'm curious your thoughts around how do we get, you mentioned just now awareness, but beyond that, how do we get some level of grip on the whole issue of updating these firmwares on, you mentioned Nest. It's I think of something like that from, sort of a multi-step pivot type attack, right? Get into an S box and then turn around and start going after the rest of the network. How, awareness is great, but, the average consumer is not going to be getting aware anytime soon, unfortunately. Any further thoughts around how we can, as an industry, take care of that?
We need to get better at providing visibility for, did something go wrong? Did something change? Am I running what I think I'm running? That, I think, it has to be one of the biggest things that changes over the next 10 years, I hope. And we also need to get better at standardizing a way for us to check all of the firmware running on a particular platform, because, for example, the bad USB hack, that was particularly problematic, because you can write to the FISM USB controller, but you can't read from it. So you can program it, but how do you know that it wrote what you programmed it to do? So, and we have the USB stack, network cards, BMC, PCI option ROMs. We have Thunderbolt, SATA, SAS, hard drives, keyboards, and even gaming mice have their own firmware. So it's like you said, it's not just BIOS. BIOS is what Intel does and what Intel can control greatly. But getting all of these small embedded systems that work together that all play a factor in firmware security, and having a way to have visibility and have a red alert somewhere go off and say, hey, something changed, something's not okay. I think that is the biggest thing for consumers, to be able to be more reactive and feel like they have more control over their devices. In some ways, firmware really is kind of the Wild West and back to 1999, because some of our limitations and lack of industry standards and fragmentation.
Now, you rattled off quite the list of all the different places where firmware is going to be lurking about the house. And whether it's, like you said, fridges, possibly even vacuums, gaming mice, etc. And our viewers can perhaps see, but our listeners don't see the pretty awesome rig that you have behind you. There's a lot of cool hardware tools, a lot of cool gadgets. And so you are surrounded by some ability to do some analysis of the hardware. So I'm kind of curious, too, for our listener, someone who wants to get into this space, how accessible is it to get into hardware hacking? And, from the start, from the aspect of either software tools that we need, or do I need a budget of a few $1,000s, a few $100s? How painful is that going to be on my wallet?
It depends on how much money you want to spend. If you have a few $1,000s, then there's a lot of cool toys that you can get. But if you don't, this is a great time to do hardware hacking. We have a lot of researchers coming up with awesome, cheap, great tools. You can get a multimeter for $10, and that's probably a really good place to start. But Joe Fitz recently released his TieGuard that can do UART, I2C, SPY, JTAG, USB, and that's $45. And you get like a bunch of protocols and functionality with that. You can get a BitMagic logic analyzer for another $30, and that allows you to do logic analysis of the bits. You can clip onto the little feet of your components and look at the bits going in, going through the buses. You can get an FTDI for not a lot of money also on Adafruit, but you probably could use the TieGuard. Will probably do all you want to do. And then if you have more money, you can get little FPGAs like the Icebreaker or Luna for USB, or the Great FET. Those are coming higher at more of $100 range. And if you want to do glitching, you can do glitching for $250 now, thanks to Colin O'Flynn's Chip Whisperer. So a lot of these tools that used to be thousands of dollars, you can now get for $10, $20, $40, which is super exciting. A lot of these are open source too.
That is pretty amazing. Oh.
What about going a little bit lower still? What can someone? I mean, again, it's I'm really curious to hear your answer on this. So people can get into glitching, or let's go back and say bus part of one of those things and start playing with it and just doing analysis and seeing what's going on. But at least from my first thought as you were talking there, it seems like you'd want to have some understanding of the firmware itself. So what's your thoughts about someone just getting into this for free with an open source simulator and just actually learning how that stuff works in the first place?
I would either watch some talks and demos, like Colin O'Flynn, for example, has all of his walkthrough, his tutorial for his tool online, and Joe Fitz has a bunch of stuff out there too. But take a class, Joe. I mean, if you're able to, that's not probably $10, but I started out taking Joe's class, and that was like close to 10 years ago now. And now I sometimes help him deliver this class, and it's amazing to see folks who have never touched hardware in their lives clip onto the components and see the bits go through and understand, try to figure out which one's the clock and which one is the input and which one's the output and what's going on. And having them on their first day go from never having touched hardware to doing a kernel bypass and having that aha moment of, oh my God, I just did this. If I just did this, it's not as hard as some people might think. What could someone who's been doing this for 20 years actually do, right?
Cool.
You've been talking a lot about for like the classes that are out there, and you are running besides PDX, you're a member of many conferences, Black Hat USA. What have you seen about the community of people that have come in just to do this type of hardware hacking? Because you described it can be pretty neat for someone to come in and basically almost see the physical bits, the zeros and ones going by. So what has that community been like, and how has that been a positive thing?
I love the hardware community. I feel that hardware people are awesome. No offense to software people. I am a computer science major. But I've found them to be really open, really excited about hardware. I met Alyssa Milburn, that I've looked up to for a long time. I saw her Black Hat talk and on hardware wallets, and I've always thought she was super cool. I met her last week, and she just said, "Hey, you want to get together every month and talk about hardware?" Yeah, I do. My advice to folks who want to get into the hardware scene is just follow a tutorial, buy an Arduino, join a makerspace, a hackerspace, start doing things, ask for advice and for help from either the people writing those tutorials or the people who you look up to. They're usually really cool, nice people. So don't be scared. Like the Nike philosopher once said, just do it.
Now, speaking of just do it and creating, you shared with us, and I think we have it posted on our show notes now, some great photos of just some hardware hacking that you've done. And I have to admit, one of my favorites is a mask whose mouth moves as you speak. And you've done some really cool LED, anything neon just speaks to my heart. I think that's cool. And where I'm going with that is that hardware seems to have a lot of very visual, cool creativity behind it too. So I'm kind of curious, as you're describing this, the very positive, friendly aspects of this community, are there some things that you would recommend or some takeaways that other communities could do, whether it's software or just others, to just kind of foster that type of collaboration, that type of openness that actually welcomes a lot of different people of various backgrounds, just to say, want to hack some hardware? Here you go. Let's build something. Let's break something.
Absolutely. I think it's very important for me personally. It's very important to share that hardware is not just math and boring and dirty labs and it can be glamorous and exciting and fun. And I create my LED dresses and shoes and my hardware implant acrylic nails and my little face masks that can speak, and maybe a little. This was the B-Sides badge for last year because it was kind of a different year. So this one can speak when you speak, which is exciting. And if you blow it a little kiss, it'll smile. There we go. So you can have some facial expression in these pandemic times. But yeah, have fun with it. And I think people who are really good into arts and crafts or art in general, they're very detail oriented and very hands-on, would be great at hardware. So if you're an arts and crafts person like me, then you'd probably enjoy hardware.
And that's definitely an aspect of, the building side of things. Have you seen a similar, that kind of just crafty perspective, or just that different type of threat modeling thinking perhaps influence the way that people also break apart devices or misuse or figure out how to abuse devices in new and interesting ways?
Absolutely. Part of that creativity to wonder, like, I wonder what that does, or what if we did this, is critically important to having a diverse and different way of thinking, right? Because the way we usually do validation is we design this thing, does it do the thing we want it to do? But security is all about what else could it do? Is there anything else that I could get it to do that it's probably not supposed to do? So having that creativity and kind of that fresh mindset is super important. And I honestly prioritize my happiness and my enthusiasm as one of the things that makes me a better engineer. So I try to make sure that I leave for work and I come back from work excited and, with curiosity of what else could we do? What if I try this tomorrow?
What if I try this? Now, not to go the opposite end of the spectrum here and say top 10 lists. So OWASP, of course, talks about top 10 lists. And we have cross-site scripting, SQL injection, and I could go on, but it gets pretty boring. But those are honestly, flaws of what could go wrong in the software. It doesn't really have anything to do with what the actual app is. And you've been using the phrase, which I think is very fair, it depends. That's a pretty common phrase. It depends, or what's the context here for security discussions. And even in your, I think it was your first talk at DEF CON, you had some fun sparking smoke that was not involved at all in software and was just some creative ways of misusing devices. So I think, that was a really cool talk that I encourage all of our listeners to go find, and we'll throw a link out there in the show notes as well. But that aspect of talking about what could go wrong or how could these devices be misused, do you have sort of a mental top 10 list or a top 2 list of the things that you look for? And here I'm thinking less about just is ASLR turned on, or things that Chipset, for example, could just go through and check for you automatically, thinking more of just what is the project, or what is the product, or what are some creative thinking that might be applied here? Just some sort of ways of saying, maybe the short way of asking this question is, what's kind of your hardware or firmware threat modeling departure point?
To me, threat modeling is a cornerstone of good security. So knowing exactly what you're trying to protect, what your asset is, where it's stored at rest, how it's protected at rest, and how it moves during the different flows of the program is very important. And it's all APIs are always a good interfaces are a good point to make sure that things potentially don't go wrong. Always go look for math. That's always a still a great BKM to go find the math. We've found in our team that software complexity is also an interesting thing. If complexity is more than 20, I think your code is essentially untestable. So even so going to look for more of those complex code paths is important from the software perspective, from the firmware perspective. From the hardware perspective, it's always nice to think, could I figure out a way to use the physical properties of this system against itself somehow, whether it's power or EM or something fun, turn off the thermal sensors or something, right? How could I attack this make this thing attack itself, maybe? I think those are some. I hope those are useful.
No, I think
one of my Raspberry Pis. Sorry, real quick. She's reminded me. One of my Raspberries, the plastic case I noticed over the weekend has turned into this melted thing. So I think someone was in there. How about I unmute myself? Sorry, and having a little bit of fun with the thermal sensor. So maybe someone's been listening to your talks, Maggie.
Yeah, I love hackathons for that reason. It's anything goes, and it's figure out how to break your security objectives in any way. So yes, thermal sensors are totally game.
Thermal sensors game, everything's game. One of the things about you're describing too about the community and getting together is that also, I'll say fortunately, hardware hacking is pretty physical, and it's hands-on, and it's also a community, in-person community, perhaps helps a bit more, so you can tinker with items. With the pandemic, or hopefully with as things are getting better in the future, are there ways that you would recommend to people you've mentioned watching some videos online, mentioned some great resources there. Are there some other ways that you'd recommend, or tricks or techniques that people can just also play with this in their home, and perhaps do this safely, if you will, rather than sticking a screwdriver into a socket type of testing?
Yeah. Some yellow engineering, that's not always the safest, but there's a lot of CTFs challenges online from many conferences. Those are always a great way to get kind of like your foot in the door, and there are starting to be some hardware ones. And maybe I'll share some links later for hardware or more firmware specific ones, because they tend to be more software. But those are still great ways to get more into like baby steps of security and trying to solve challenges. And that's always fun and can be done remotely. But yeah, I would buy, pending availability of parts and all, but trying to buy and do something at home. I do a lot of PCB art that I really enjoy. So it's been fun to hunker down and work on some hardware and work on some soldering and get in the zone. It makes the pandemic times go a little faster.
Anything from that, anything to make it go faster, indeed. Looking forward, is there something that you want to sort of tease for us, or to put on our radar to look forward to, or is there something, I love asking compound questions, so I'm just going to throw this all to you at once, or is there something in the future, a year from now, 2 years from now, that you'd also like to see hardware, firmware security improved by, whether it is they get their own OWASP top 10 list, or there's actually something different or better about some countermeasures, ASLR turned on by default, those types of things?
I hope that there's a lot better visibility, that we get some kind of industry standard, that products like Eclipsium or EDR solutions become better at giving us information on the software level and warnings about things that could potentially be improved. So hopefully we get better at securing the foundation of our platforms. And as far as exciting things coming up, I don't know if the public is aware. I used to be in BIOS land at Intel, and I think the community was pretty engaged with the Intel bug bounty, but the same bug bounty applies for FPGAs. So if you're interested in FPGAs, our newest FPGA, our AgileX, has all the security features, anti-tamper, side channel protections. So if you're interested in hardware and FPGAs, go at it, submit your bugs to us, and we'd be happy to have you be part of our bug bounty. And also, if you're interested in FPGAs and hardware security, PSG is hiring. So if you want to shoot me a DM and work for us, that would be super exciting as well.
That'd be great. Yeah. What a fun way to turn hardware hacking creativity hobbies into a job, get paid for it on a daily basis.
Yeah. Intel makes great technology and they pay me to break it. So it's the best. I highly recommend.
Now, I know that I guess if a few final things, because I'm really curious about this topic, and I honestly haven't played with like the Raspbies or Arduinos and the hardware stuff myself. I'm going to throw a question over to John real quick. John, have you created something, put something together that now you're worried about the security of from the hardware firmware standpoint, that we should probably be throwing Chipset against, or some of these techniques, and maybe take a walkie-talkie to it or throw some EM against it?
That's interesting. I play a lot with that stuff, but I always have it behind a firewall, and I usually have it on a separate DMZ. So, Node MCUs, I'm not quite going down usually to the level that Maggie's playing with. I've got I've done some of that in the past. I love the space. I think you have to be. I mean, I guess if you're the interesting thing about if you're working with Arduino, let's go there for a second, is the code you're writing there will end up becoming the firmware on that chip, right? So you suddenly get, in some of these cases, that gap between the OS goes away. So as you start working with the microcontroller, so I guess there is sort of a chance of it. I guess the one last question I have for Maggie that I wanted to throw in if we have time is have you started playing with, what's your thoughts around using, we've been talking about Rust for a while. A lot of the larger companies are starting to use it to target what could be their more insecure code. So are you, have you played with Rust? Do you like Rust? Do you think there's a future for it on the firmware side of things or hardware side of things, or any thoughts around that?
I do, and I'm excited for it. I've been starting to see more and more Rust projects around Uefi, for example, and I'm all for it. I'm super excited. I think it's time that we have these types of protections for lower level code. So I'm super excited for Rust.
Cool. And I have one question just come in from the listener, a listener, excuse me. Can a bug bounty tester get access to Intel demo depot gear for testing? Or who would they contact?
Not as far as I know, but if you're interested, reach out to me and we'll see if there's something we could do.
Cool.
Oh, very cool. Yeah, so I think that will be the reaching out, the combination, that final aspect there about Rust. That's the putting together, bridging that gap between I guess it is firmware, but the hardware side of the hardware group and the software group, because clearly we've been talking about hardware, but we can't ignore the software side of things, as you rightly pointed out, Maggie, too. There's hitting the API. The API is going to be a lot of interesting information there, and you were mentioning side channels too, and what does the math look like on these? A lot of that is due to software implementations. So I think there's a great message there, is that build those open communities so that people have fun coming to the hardware, and build your collaboration with the software team so that they actually want to talk with the security team, want to talk with the hardware team. I think those are all great messages. So I want to thank you for that.
Absolutely. Thank you so much for having me.
This was great. And if you'd like to hear more about Maggie's work, especially her first DEF CON talk, go check it out. Spark Smoke with walkie-talkies and hairdryers. It's hardware in surprising in fun ways. I want to thank Maggie once again. I want to thank John and all of our listeners for joining us for this interview. We're going to take a quick break and return with news of the week.